Hello and welcome to my second tutorial on statistics 2. In this tutorial I'm going to show you how to operate the Ogive curve, how to draw the Ogive curve and use it to determine percentiles and deciles. I'm just going to take you through how to draw the curve and all that, and again how to use it to determine quartiles, percentiles and deciles. You can also use the same to determine median. And again, as an additional part of that, I'll show you how to calculate quartiles, percentiles, and deciles without using the Ogive curve. And I hope you enjoy. And let's begin. You're given a question here about the question says the table shows performance of students in the mathematics test. Use the data to draw the Ogive curve, and again use the curve to determine the following, the ones listed there. Now, the information that is given here is information that has to do with the performance of students in a math test. So what you have here is 1 up to 10 students, 2 students only had or scored somewhere between 1 to 10. 6 students scored between 11 and 20. 15 students scored between 21 and 30. And 4 students scored between 71 and 80. 2 students were excellent students, scored between 91 and 100. The total number of students were 120. We shall see that. And so let's begin drawing the Ogive curve. And this is what we do. We first of all need to develop the cumulative frequency column. The data that was given had classes and frequencies, but now we need to develop the cumulative frequency column, which starts with 2. The next value is 8 because it is this 2 plus 6, 8, this 8, and this 6. The next value is 23 because this 8 plus 15. The next one is 43 because it's 23 plus 20. The next one is 67 because it's 43 plus 24, and on and on. The last figure should be 120. But what does this mean? If we argue this way, the first class, that is 1 to 10, shows the number of students who scored between 1 to 10. So we say only 2 students scored between 1 and 10. That's why the cumulative frequency here figure also is 2. But if we want to know the number of students who scored between 1 and 20, we would have the 2 plus 6, because this 6 also scored somewhere between 1 and 20, although specifically they were between 11 and 20. So 2 plus 6 give us a total number of students who scored anywhere below 20, or 21 to 20. The next thing also 23. It means we have 23 students who scored between 1 and 30. 2 of those were in the first class, that's from 1 to 10. 6 of those were in 11 to 20, and 15 of those were between 21 and 30. So if you add those 3, you get 23. So these figures actually are gotten by adding cumulatively a previous class from what you have, and on and on and on. And so that's how I develop the frequency. I'd explained that in a previous tutorial. Maybe you need to check it out. The next thing is how do you plot now the Ogive curve? We will need to have the cumulative frequencies and the plotted against the upper 2 class limits. So cumulative frequency will be on the y-axis, and upper 2 class limits will be the x-axis. Again, here it doesn't look like we have 10.5, 20.5, 30.5, and on, but that's actually what I used. Only that in the graph it might not be seen, but that's what I used to draw that. And so that means you'll need to have the cumulative frequencies on the y-axis, but you transform these classes to class limits. Add 0.5 for every upper class limit. For example, 10, add 0.5 so that you get 10.5. 20 plus 0.5 so that you get 20.5. 30 will be 30.5. 40 will be 40.5, on and on up to 100.5, so that you plot that. If you have the cumulative frequency on the y and the upper 2 class limit on the x-axis, you'll get something like this, and you can try it out. Another comment that's necessary is that this curve should be an elongated S, so that can always help you check your work. If it doesn't look anything close to that, maybe you are not right. The other thing is this curve should be anchored on the x-axis. Ensure that yours is anchored there. That's what the examiner requires. Having plotted that, then we need to go to the calculations. How do we calculate median using the Ogive curve? The first thing we'll need to do is we arrange the data in ascending order, and then you get the middle value. So we have 120 values. Getting the middle value will be the 60th, where 60 is just 1 over 2 times 120, and so that's the case there. We get 60th value, And having got that, then we go to the cumulative frequency curve. That's the Ogive curve, and look for 60 along the cumulative frequency. Move until you get the curve, and then you go down and get the corresponding value here. And my estimate is 47.5. Try it out and see what value it should be. It might not be very accurately the same, but they are within some range there. The reason why we have different values is because of the level of accuracy that someone has used. My graph has 5 small squares for every 1 square. So maybe if you used 10 small squares for every 1 big square, your accuracy could be more. And so maybe you even be able to have 2 decimal places here. And so you can try it that way and see what figure you get. The lower quartile, which is Q1 in mathematics, lower quartile is normally called Q1. Involves dividing the data into quarters. So we have the first quarter, second quarter, third quarter, and the last part. The second quarter being what we've just obtained, that's the median. The first quarter, therefore, is just 1/4 of 120. 1/4 of 120, and that value there would be the 30th value. Since the quarter of 120 will be that value. So the first quarter will be 30, the second quarter will be 60, the third one will be 90, the next one will be 120. So where is that value? Again, you move to the cumulative frequency curve, and you need to check out where is that here. 30 is somewhere between 20 and 40. So where is that? It is just midway that way, because yeah, it's just between 20 and 40, exactly between there. So you draw a straight line like that and go down, and then remember that these lines that you introduce on the graph should not be continuous, so that the examiner will not accuse you of having or adding additional information that is not necessary or was not required. Should always be broken, therefore. So the figure that you get down here is 34. It means if this data was arranged in ascending order, the 30th student, which is a lower quartile student, should have 34. The upper quartile will be done the same way, only that this time around it have 3/4 of 120, which is the 90th student. The 90th student got what? We go to the Ogive curve. Where is 90? Somewhere between somewhere between 80 and 100. Midway, actually. So you move across, go down, you get the value. For me, 57.5, and that'll be good. The next thing is the interquartile range. So interquartile range is the range within which the quartiles appear or exist. So that'll be the upper quartile minus the lower quartile. Q3 minus Q1, which will be 57.5 minus 34. In our case, it'll be 23.5. Basically that. And that's clear. The next thing is quartile deviation. The quartile deviation is we're trying to estimate how much the upper and lower quartiles deviate from a median. How do they deviate? So since this is the interquartile range, we should just divide it by 2. Interquartile range is, quartile deviation is the quartile range divided by 2. In that case, it will be 23.5 divided by 2, which is 11.75. And I hope that's clear. So basically, what we do to estimate median, lower quartile, upper quartile for using the Ogive curve is just you look for, say, the middle value, which is 60th, or the lower quartile value or upper quartile value, and read the corresponding value or the observations. Remember, the y-axis gives us number of students who scored with the number of students, but the x-axis gives us the value they scored. For example, this 20 means the 20 students scored somewhere from just below that. You see that? 40 means that 40 students scored somewhere before 40 again. 100 students scored somewhere between 0 and between 1 and say 60 or 50 something. And so that's what it means. The y-axis is actually the number of students who scored a certain value that is given by the x-axis. So having explained that, now we go to the percentiles. Percentiles, they are similarly done as we have done in the quartiles and median, but in this case now, the data is not divided into quarters, but into 100 portions. There were 120 students, but can we divide 120 into 100 portions, equal portions? If it was possible, what would be the value of the 37th portion? That's what we are answering. What would be the 37th value? The arranged observations were divided into 100 equal portions. We'll get the 37th percentile by just getting 37 all over 100 times 120. What this means is that we have 120 divided by 100, so that we get 120 students divided by 100 portions. We get 37 of that, and so that'll be 44.4th value. So we now go to the Ogive curve. Estimate where is 44.4, somewhere here. Again, please familiarize yourself with how to use the small squares to get values with more accuracy. For me, it is somewhere about where I have the red broken line there. So read the corresponding value on the x-axis, and that will be 41.5. Again, 69th percentile, it'll be 69 over 100 times 120, which will be the 82.8 value. And if you go to the graph and look for the 82.8 value, for me it's somewhere about there, and so you go down to read the corresponding value, it'll be 55.5. Having said that, now we are free to go to the deciles. Now the deciles involves dividing the data into portions, into 10 portions, yes. But in this case, each portion will have 12 students. So we have 12 students, 12 students, 12 students, 10 times. So that 12 times 10 will be 120. And so the question would be, what would be the third value, what would be the fourth value, and all that. So the first question is the third decile. What would be the third value if we arrange the observations in ascending order and they're divided into 10 equal portions? The question would be answered this way. It'll be 3 over 10 times 120, which means we have 120 divided by 10 times 3. Why? 120 students are divided into groups of 10, into 10 groups. That means every student will have 12. Every group will have 12, but we want the third group if they are arranged in ascending order. And that group will be the 36th value. And what will be the score? 36th value we read along the cumulative frequency, just read across. Now 36 is just a small square below 40, and then you go down to read the corresponding value along the x-axis. That will be 7.5. The 8th decile again will done similarly, so you'll have 8 over 10 times 120, which will be the 96th value. And reading it from the graph, we'll have 96 is appearing somewhere below 100, actually a small square below 100. And so reading on the x-axis value, you will get 59, and that's basically what we do using the Ogive curve to get percentiles, deciles, even quartiles, and median actually. Now, having said that, we go to the last portion of the lesson where I'm going to show you how to calculate the quartiles, percentiles alternatively from the Ogive curve, in an alternative way that you don't use the Ogive curve. And this is what you do. We use a formula that is equivalent to the median formula. The median formula was given as this one here: LT plus n over 2 minus CF all over FM, all of that times I. And in the previous lesson, I explained what LT, N, CF, FM, and I means. But we're going to get on to the details of that. I just need to say that the formula is equivalent to this, only that the n over 2 is slightly altered to suit the particular question that you're answering. For example, if we are doing the 37th percentile, instead of having 120 over 2, we are going to have 37 all over 100 times 120. Okay, this was sort of getting the half of 120. Now we wanted 37% of 120, which is 37 over 100 times 120. So like we've done in the previous case, we'll have 37 over 100 times 120, which gives a 44.4 value. But now we go to the table, not the graph, right? We go to the table and try and ask ourselves, the 44.4 student, what did the person score? In which class was that person? 44 is somewhere after 43, is also below or before 67. So it is in the 41 to 50 class. Why? Because the students who scored between 1 and 50 were 67, but students who scored 1 to 40 were 43. So the 44th student was in the class next there. It's among these 24 students. Okay, so that's the case there. Now that gives us the class 41.5 to 50. Sorry, 41 to 50. And this defines what LT will be, what CF will be, what FM will be. N is 120 and I is 10, all through. Lower two class limit of that class will be 40.5. Why? Because it is 41 minus 0.5, which is 40.5. N will be 120, CF will be 43. Why? Cumulative frequency just above the median class. Sorry, just above the 37th percentile class. That class was 41 to 50, this one here. So the class above the cumulative frequency just above that will be 43, which is around there. Alright? Then the next thing is the frequency of that particular class. It is 24. Very easy. And the class width is 10. Put the values in the formula and operate, you get 41.5. The same thing you'll do with the 69th percentile. We'll have 69 all over 100 times 120. So that you get the 82.8 value. That class there will be 51 to 60. Okay? 82 second value is, where is it? Somewhere after 67 but before 99. So this must be the class, because 67 means 1 up to the all the students, that is 2 up to the 67th students. 67 students scored between 1 and 50. But if you go to we want the 68th student will be in the next class, 69 the same. So this 82nd student is among these 32 that are in that particular class, 51 to 60. Having said that, the 51 really then will define what LT will be, what CF and FM will be. Our LT, which is lower true class limit of the 69th percentile class, will be 51 minus 0.5, which is 50.5. N is 120. Cumulative frequency just before the 69th percentile class will be this class here, the value just above that, which will be 67. Alright? The frequency of that particular class is 32. I just mentioned that. The class width is 10. Put the values in the formula and you operate. It'll be 55.44. Same thing you do with the deciles. We use the median formula or an equivalent of it, and again, as I said, in the percentile case, the n over 2 will be changed similarly to suit the particular question that you're doing. And this is what we do. The third decile will be obtained by having 3 over 10 times 120, which will be the 36th value was the third. In this case, the students have been grouped such that we only have 10 groups, 12 students per group. The third group, if they are arranged in ascending order, will be 36th. That group will have that 6th. So what will be that value? We go to the table. Where is 36 in the cumulative frequency? It's somewhere after 23 but before 43. So that class is 31.4, 31 to 40. And that means that that being our class, the class defines our LT, our CF, our FM. Alright? Therefore, the lower true class limit will be 30.5 because it's 31 minus 0.5. The N will be 120. CF will be 23 because that's a class just above the median class, just above the third decile class. Third decile class is the 31 to 40. The cumulative frequency just before that is 23. But the frequency of that particular class is 20. So FM is 20 and class width is 10. Put the value in the formula, operate, you get 37. Having said that, we go to the 8th decile. 8th decile is done very similarly like that. It is 8 over 10 times 120, which gives us a 96th value. That's the 96th value. That's what we want. Where is it in the cumulative frequency? It's just before 99, but way after 67. So that class must be 51 to 60. This one defines our LT, our CF, and FM. The lower true class limit, that is our LT, will be 50.5 because it's 51 minus 0.5. The N will be 120. Cumulative frequency just before the 8th decile class, CF, is 67. Why? The class is 51 to 60. The cumulative frequency just before that is 67. Again, the frequency of that particular class is 32. Alright? And the class width is 10. Put the values in the formula and operate. You get 59.56. And that's it. That's how you calculate them accurately without having errors of any nature, like would have introduced you were using the Ogive curve. I would like to compare these values with the values that you get when you are operating using the Ogive curve, and this is what you get. Well, of course, you'll not need to do this in an exam, but just for the sake of knowledge, maybe you need to do that. When you're using the Ogive curve, the 7th percentile was 41.5. The formula gave us 41.08. The 69th percentile gave us 55.5. The formula gave us 55.544, and on and on. So these figures are very similar or closely related. However, the formula is more accurate than the Ogive curve. This introduces some sort of human error. And that brings us to the end of our lesson. Check out for my next lesson. Will be coming in 2 or 3 days, where I'll be sharing with you about the measures of dispersion, that's variance and standard deviation. Please always like, share, subscribe, and I'll appreciate your questions, your comments, even corrections.